Welcome to our channel. Today, we're unraveling the mysteries of unit testing, an essential software testing technique that forms the cornerstone of software quality assurance. Join us as we explore what unit testing entails, its significance in ensuring code quality and reliability, and best practices for effective implementation. Let's dive in. Introduction to unit testing. Definition: unit testing is a software testing technique that involves testing individual units or components of a software application in isolation to ensure they behave as expected. Purpose: it aims to validate the correctness and reliability of individual units of code, such as functions, methods, or classes, and detect defects early in the development process. Key concepts of unit testing. Testable units: units of code that can be tested in isolation, typically functions, methods, or classes, with well-defined inputs and outputs. Test cases: specific scenarios or conditions that test the behavior and functionality of individual units, including typical cases, boundary cases, and error conditions. Mocking and stubbing: techniques for simulating dependencies or external systems in unit tests to isolate the unit under test and focus on its behavior. Benefits of unit testing. Early defect detection: identifying and fixing defects in individual units early in the development process reduces the risk of defects propagating to higher levels and becoming more expensive to fix. Improved code quality: unit testing promotes code modularity, encapsulation, and reusability, leading to cleaner, more maintainable, and more reliable code. Regression prevention: unit tests serve as a safety net for code changes, ensuring that existing functionality remains intact and preventing regressions. Faster feedback loop: unit testing enables developers to receive immediate feedback on code changes, facilitating rapid iteration and reducing time to market. Best practices for unit testing. Test early, test often, integrate unit testing into the development process from the outset and write tests concurrently with code to ensure comprehensive test coverage. Keep tests focused and independent. Write unit tests that focus on testing specific units of code in isolation and avoid dependencies on external systems or other units. Use meaningful assertions. Ensure that unit tests include meaningful assertions that verify the expected behavior and functionality of the unit under test. Automate testing. Automate the execution of unit tests using testing frameworks and tools to streamline the testing process, increase efficiency, and ensure consistency. Refactor tests regularly. Refactor unit tests regularly to maintain readability, reliability, and maintainability as the codebase evolves. Unit testing process. Test setup. Set up the environment and test fixtures required to execute unit tests, including mock objects, stubs, or test doubles for dependencies. Test execution. Execute unit tests using a unit testing framework, providing inputs and verifying outputs to test the behavior and functionality of individual units. Test result analysis. Analyze test results to identify failures, errors, or unexpected behavior and diagnose the root causes of issues. Issue resolution. Fix defects or issues identified during unit testing, refactor code as necessary, and rerun tests to ensure that issues are resolved satisfactorily. Challenges in unit testing. Legacy code integration. Testing legacy code that lacks unit tests or was not designed for testability can be challenging and require refactoring efforts. Time and resource constraints. Limited time and resources may impact the extent and depth of unit test coverage, requiring prioritization and focus on critical areas. Mocking and dependency management. Managing dependencies and simulating external systems or components in unit tests using mocking frameworks can be complex and require careful consideration. Conclusion. Unit testing is a fundamental practice in software development that plays a crucial role in ensuring code quality, reliability, and maintainability. By following best practices and integrating unit testing into the development process, organizations can identify and fix defects early, improve code quality, and build robust and reliable software systems. Stay tuned for more insights into software testing methodologies and best practices. Thanks for watching. Please subscribe our YouTube channel.